7.3, comparing quadratics notes. We are going to start off with something super basic. Y'all, the parent quadratic function, the mother of all the quadratics, is just y equals x squared. Don't get this confused with standard form of a quadratic, which is y equals ax squared plus bx plus c. It is imperative, it is so important that y'all know a is the number with x squared, b is the number with x, and c is the number on the end, right, the constant. Because if you don't know that, you're really not going to be able to utilize any of the information in this lesson. So, all right, so remember, a is with x squared, b is with x, c is by itself. So, if a is increased, right, if this number is increased, the parabola, we're going to say, gets narrower. Let me just do a quick for instance on my calculator. If my original parent function is y equals x squared, but then I increase the a value, right? Right now a is 1x squared. If I make a bigger, like let's say 3x squared, okay, well then look at my graph. Oops. Here's my original x squared. Here's 3x squared. So we can see that it gets narrower, right? If we decrease a, if we make a smaller than the original, so smaller than 1, let's say 0.5 x squared, then let's see what our graph looks like. 0.5 x squared, here's my original x squared, and here's 0.5 x squared. Okay, we can see that if we make a smaller, the parabola gets wider. And then finally, if a's sign changes. So for my second graph, let's make it y equals x squared, but let's put a negative in the front, so negative x squared. What does this look like? Here's my original x squared. All right, it flips it over. So if the sign changes, the parabola flips over. So those are some basics. If I were to generalize what a does, I would say a changes the shape and or direction. Okay. Now we're going to look at this chart, and this chart is very confusing. I'm not going to mince words here. It's confusing. Sometimes when we change our graphs, we can have a vertical change or a horizontal change. They look very, very similar on the graph. It's actually impossible to tell from a graph if it's vertical or horizontal. You need a little bit more information. So the key to knowing how to do this comes down to whether or not you've got parentheses. If I do not have parentheses, it's a vertical change. So let's go through here. Let's see. If y equals x squared becomes 4x squared. Okay, well that's a vertical change because there's no parentheses. Now, it's a vertical stretch or compression. We'll talk about that in a minute. Here's another one. This is a vertical change because there's no parentheses, right? Look at this has parentheses, this doesn't. We're looking for no parentheses. Now, if it does have parentheses, like this one, then it's a horizontal change. All right, horizontal change has parentheses. So this is going to be a horizontal change. And the last one will also be, right, because we got parentheses again, we got another horizontal change. I honestly think that that's probably the biggest takeaway from this lesson. No parentheses is vertical change. Parentheses means horizontal change. The next part of this gets very confusing. All right, guys, it gets very confusing. So let's try and take that as best we can. Just to really briefly explain something, if I've got these vertical lines around my variable, it means the absolute value of a. All that means is don't worry about the positive or negative sign. All right, if that number a is bigger than 1, then I've got a vertical stretch. So look at my vertical ones, my blue ones. Okay, 4 is definitely bigger than 1, so this is going to be a vertical stretch. Now, I've got a vertical compression if that number is between 0 and 1, essentially if it's a fraction, right? Less than 1, between 0 and 1. Just like this one is 1/4, so that's going to be a vertical compression. Let's look at another example now. We'll move on over to horizontal. If in a horizontal change, if the number is greater than 1, it's actually a compression. So here, since I got a 3, this is going to be a horizontal compression. And then finally, in horizontal change, if I've got a number less than 1, it's actually a horizontal stretch. The reason this is complicated is because look at these two. On a graph, these would look the same, but one's a vertical stretch, one's a horizontal compression. It all depends on the equation. Guys, remember, if it's got a parentheses, it's horizontal, and then you're going to follow along to this guide, and we will work more with this a little bit later. The last section here is talking about changes in B, so the number in the middle with X, right? Changes in B, remember, I'm going back to this, talking about the number in the middle. That just was not good. All right, so let's go ahead and look. If B is increased, the parabola shifts left, just kind of opposite what you would expect. If the B value is decreased, the parabola shifts right. I'm kind of glazing over this one because we don't use it very much. Finally, changes in C. Well, C, I don't know if you guys noticed, but C is always the y-intercept. If you've got an equation in standard form, C is your y-intercept. So if we increase C, it's messing with the y. So if we make it bigger, it's shifting the graph, right? Shifting the graph up. If we decrease C, if we decrease the y-intercept, it shifts the graph down. All right, so we've got the A, the B, the C. If I had to summarize one more time, you guys, remember, and I'm not sure what this is doing. There we go. All right, if I had to summarize, remember, A changes the shape or the direction of the parabola. B shifts its left or right, or controls its left or right shift, and C controls its vertical shift, up or down. Now, if you want to know the difference between vertical and horizontal change, look for parentheses. If they're there, it's horizontal. If not, it's vertical. And we'll talk more about how to kind of remember these as we go forward.